Space and Science News. With James. In the far reaches of space, a cosmic mystery has been unfolding for nearly 3 decades. A celestial object, once thought to be singular and well understood, has been hiding a secret that's about to change everything we thought we knew about brown dwarfs. Today, we'll be talking about the enigmatic Gliese 229B, because why not explore one of the most intriguing astronomical discoveries of our time? Picture this: a faint, cool object orbiting a distant star. Scientists thought they had it all figured out. But something wasn't adding up. The math was off, the observations didn't match the theories, and astronomers were left scratching their heads. What if everything we believed about this cosmic oddball was wrong? Enter a team of determined researchers armed with cutting-edge technology. Their findings? Well, they're about to turn the world of astrophysics on its head. We're talking about a revelation that not only solves a long-standing puzzle but opens up a whole new realm of possibilities in our understanding of the universe. Are you ready to have your mind blown? Because what these scientists uncovered about Gliese 229B is going to challenge everything you thought you knew about failed stars and planetary formation. Let's dive deep into this subject and unravel the mystery of the brown dwarf that wasn't quite what it seemed. For nearly 3 decades, Gliese 229B has remained one of astronomy's most perplexing discoveries. Identified in 1995 by a team of astronomers at Caltech, this celestial body was groundbreaking, becoming the first confirmed brown dwarf, a so-called failed star that occupies the nebulous category between stars and gas giants. Brown dwarfs are too massive to be considered planets yet too small to sustain the nuclear fusion that powers stars. This peculiar hybrid nature alone was enough to make Gliese 229B intriguing, but it was its behavior that left scientists scratching their heads. At the time of its discovery, calculations pegged Gliese 229B's mass at roughly 70 times that of Jupiter, a hefty weight in cosmic terms. However, its brightness, or rather the lack of it, posed an enigma. Brown dwarfs were expected to emit some level of faint light due to their residual heat and energy, but Gliese 229B glowed far less than anticipated. This baffling mismatch between its mass and luminosity sparked heated debates in the scientific community and prompted hundreds of research papers attempting to explain the anomaly. Was it unusually old and thus had cooled down more than expected? Or could there be some unknown factor at play? For years, even the most advanced telescopes failed to provide clear answers. Then, a breakthrough occurred with the advent of state-of-the-art observational technology. Using the gravity interferometer and the Crier's Plus spectrograph at the European Southern Observatory's Very Large Telescope, researchers managed to uncover a surprising truth. Gliese 229B wasn't a single object but two. What had long been thought of as one brown dwarf was, in fact, a binary pair, Gliese 229B A and Gliese 229BB. Each component, weighing in at about 38 and 34 times the mass of Jupiter, orbits the other in an astonishingly tight 12-day cycle. For decades, this close configuration had camouflaged the pair as a single entity, eluding detection and deepening the mystery of Gliese 229B. The tale of Gliese 229B begins with its stellar companion, Gliese 229A, a relatively modest M-dwarf star located approximately 19 light-years away in the constellation Lepus. M-dwarfs, often referred to as red dwarfs, are smaller, cooler, and far more common than stars like our Sun. While they may seem unassuming, these stars frequently host fascinating cosmic companions, ranging from rocky exoplanets to substellar objects like brown dwarfs. Gliese 229A is no exception. When Gliese 229B was first identified orbiting this unremarkable star, it immediately stood out. Unlike stars, which are powered by nuclear fusion, brown dwarfs lack the necessary mass to sustain such reactions. Yet, what made Gliese 229B so extraordinary wasn't just its classification as a brown dwarf, it was the presence of methane in its atmosphere. This was a groundbreaking discovery at the time, as methane is a feature commonly associated with gas giants like Jupiter but not typically observed in stellar objects. The finding provided a new way to study substellar bodies and opened up a field of exploration into the nature of brown dwarfs. Despite these breakthroughs, Gliese 229B posed more questions than answers. Its unexpected dimness was an immediate red flag. Astronomers had calculated its mass and size, but its faint luminosity didn't align with existing models. Was it an exceptionally old and cool brown dwarf, or was there something else obscuring its true nature? The possibility that Gliese 229b could be more than it appeared lingered in the back of scientists' minds. For decades, the limits of observational technology kept those questions unresolved. The close proximity of Gliese 229b to its host star made it difficult to study in detail. However, the mystery persisted, and advancements in astronomical instruments eventually provided clarity. By employing the gravity interferometer and the Cryo's Plus spectrograph at the European Southern Observatory's Very Large Telescope, researchers finally unmasked the truth. Gliese 229b was not a singular brown dwarf but two, Gliese 229b, A and Gliese 229b, locked in a tight, 12-day orbital dance. Their nearly inseparable bond had hidden them from view for decades, making their discovery all the more remarkable. The tools that unraveled the decades-old mystery of Gliese 229b stand as some of the most sophisticated instruments in modern astronomy. Chief among them is gravity, an interferometer capable of combining light from 4 telescopes to achieve unprecedented spatial resolution. With this technology, astronomers managed to resolve Gliese 229b into 2 separate components for the very first time. This groundbreaking observation laid the foundation for what would come next, confirmation of a binary brown dwarf system. While gravity provided the spatial clarity needed to distinguish the 2 objects, another cutting-edge tool, Cryo's Plus, played an equally critical role. Cryo's Plus, a high-resolution spectrograph, delivered detailed spectral signatures of the 2 bodies. By analyzing their Doppler shifts, astronomers could track the motion of the brown dwarfs as they orbited one another. At any given time, one was moving toward Earth while the other moved away, their distinct velocities painting a vivid picture of their tight gravitational bond. These observations confirmed what had long been suspected: Gliese 229b was not a solitary brown dwarf. Instead, it comprised 2 massive objects, Gliese 229b, A and Gliese 229b, locked in an astonishingly close orbital embrace. Completing their dance every 12 days, the pair is separated by a distance of just 16 Earth-Moon spans. For objects of their size and mass, such proximity is nothing short of extraordinary. The intricacies of their motion extend beyond their mutual orbit. Together, Gliese 229b, A and BB revolve around their host star, Gliese 229a, in a sprawling 250-year orbit. This cosmic ballet, combining the rapid, intimate twirls of the brown dwarfs and their slow, stately journey around their parent star, is as rare as it is mesmerizing. The discovery not only solved a lingering enigma but also highlighted the extraordinary precision of modern astronomical tools, opening the door to deeper studies of binary systems across the cosmos. The discovery that Gliese 229b is actually a binary system has sent ripples through the field of substellar astrophysics, challenging existing theories about brown dwarfs and their formation mechanisms. Brown dwarfs, with their unique position between stars and planets, have always been a source of fascination and mystery. They are too massive to be classified as planets but lack the necessary heft to ignite nuclear fusion and become full-fledged stars. This liminal status has made their origins a subject of intense debate. One prevailing theory suggests that brown dwarfs form similarly to stars, emerging from the gravitational collapse of gas clouds in space. In this model, the brown dwarfs are essentially failed stars that didn't accumulate enough mass to ignite. Another hypothesis posits that they form within protoplanetary disks surrounding young stars, akin to how planets come into existence. The revelation of Gliese 229b, A and BB's binary nature has added a new layer of complexity to this discussion. The tight 12-day orbit of the 2 brown dwarfs suggests that they formed together as a pair, likely through a process involving fragmentation in a collapsing gas cloud. Their formation in such close proximity also raises questions about how they avoided merging or being ejected from their shared system during their early stages. Beyond their origin, this discovery prompts exciting speculation about other unseen binary systems in the universe. If Gliese 229b, a system so close to Earth at just 19 light-years away, remained hidden for nearly 30 years, how many other binary brown dwarfs or substellar pairs might still be concealed in the cosmic void? Advanced instruments like gravity and Cryo's Plus could be key to uncovering these hidden systems, further expanding our knowledge of substellar objects. The implications extend beyond brown dwarfs themselves. Could binary systems also exist among massive exoplanets orbiting distant stars? If so, this would redefine how we view planetary system architecture and dynamics. Gliese 229b, A and BB represent a new frontier in understanding the complex relationships between mass, composition, and formation mechanisms in the universe. As astronomers continue to study this remarkable system, it is certain to reshape theories about brown dwarfs, binary systems, and the processes that govern celestial formation. The revelation of Gliese 229B, A and BB is a major milestone, but it's just the beginning for astronomers pushing the boundaries of substellar astrophysics. This discovery has resolved decades-old questions about Gliese 229B and sparked curiosity about other hidden systems that may still be awaiting discovery. As technology advances, the tools available to astronomers are becoming more powerful, opening up new opportunities to explore the universe's most elusive and fascinating objects. Future instruments like the Keck Planet Imager and Characterizer, KPIC, and the High-Resolution Spectrograph for Infrared Exoplanet Characterization, HISPEC, are expected to lead the charge in uncovering tightly bound systems. KPIC, with its ability to directly image faint objects near bright stars, will provide astronomers with the clarity needed to study binary systems like Gliese 229b, A and BB in greater detail. HISPEC, designed for high-resolution spectroscopy, will complement this by analyzing the atmospheres and motions of substellar objects. Together, these tools are likely to reveal more pairs of tightly orbiting brown dwarfs, refining our understanding of how these systems form and evolve. But the potential for discovery doesn't stop at brown dwarfs. These techniques are equally applicable to the study of massive exoplanets. Future observations could uncover binary systems among planets, an idea that challenges our current understanding of planetary formation and stability. Such discoveries could provide new insights into the diverse architectures of planetary systems and the gravitational dynamics that shape them. Astronomers are particularly eager to find analogues to Gliese 229b, A and BB scattered throughout the galaxy. What other unusual systems might exist within the vast expanse of space? How do pairs of massive objects manage to form and remain bound so tightly without being disrupted or merging? Each discovery has the potential to reshape our understanding of stellar and planetary evolution, revealing new mechanisms and possibilities we haven't yet considered. As we continue to develop and deploy new instruments, the road ahead is full of promise. The discovery of Gliese 229b, A and BB serves as a reminder of how much remains hidden in the cosmos, and how each step forward brings us closer to uncovering its secrets. With every leap in technology, astronomers move closer to answering fundamental questions about the nature of our universe and the fascinating objects within it. The discovery of Gliese 229b as a binary system reshapes our understanding of brown dwarfs and the processes involved in the formation of celestial bodies. What was once thought to be a single, enigmatic object has been revealed as two closely bound brown dwarfs, orbiting each other in a gravitational dance that challenges long-held assumptions in astrophysics. This finding not only resolves the mystery of its unexpected dimness but also highlights the complexity of substellar objects and their evolution. This breakthrough encourages a re-examination of how objects in the intermediate space between stars and planets are classified and studied. The dual nature of Gliese 229b prompts exciting questions about the mechanisms that lead to such configurations and whether similar systems are more common than previously believed. With every advance in observational technology, astronomers gain new tools to uncover hidden companions and reveal the intricacies of the cosmos. Gliese 229b's story is a reminder of how much remains to be discovered. These tightly orbiting brown dwarfs push the boundaries of what we understand about stellar and planetary systems, opening up possibilities for new research and discoveries that could redefine our knowledge of the universe. If you've enjoyed diving into the fascinating details of this discovery, be sure to subscribe for more updates on the latest advancements in astronomy and space exploration. We'd love to hear your thoughts or questions about this groundbreaking find. Share them in the comments below. What other mysteries do you think are waiting to be uncovered among the stars? Keep exploring, keep questioning, and never stop looking beyond. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.